Another Open Cluster Management Community meetings. Today we're really excited to have Yusel to present the policy framework. So without further delay, Yusel, please take it away.
Right. Let me share my screen. I'm gonna take away the screen sharing. Okay.
Yes, please.
Right. I believe I'm sharing. So today I'm going to talk about the policy framework in Open Cluster Management project. So what is governance policy framework in Open Cluster Management project? So the policy framework here, it provides the governance capability to gain visibility, drive remediation for either like security aspects or configuration aspects of a cluster to help you meet NA enterprise standards. That's a short description in one sentence. But what exactly it does is, so for example, say you are managing 10 clusters. You may want to ensure your 10 cluster had shared a consistent configuration. And you may also want to ensure all those clusters are secure. So today, if you want to do that, you may have some homegrown scripts that helps you to configure each single cluster individually. And if you want to see the results, you may have to log into each single cluster to do that. But with governance policy framework provided by Open Cluster Management project, you don't have to do that anymore. You can just leverage the policy framework to write a policy, and then it will do its job. So here's the architecture diagram of the policy framework. So let me open it. So there are multiple components in policy framework. So on the hub, there's a policy propagator, the component in the white box. On Managed Cluster, there are also multiple components. So there's a spec sync controller, status sync controller, template sync controller. These controllers are part of the policy framework. So let me take it step back and just explain what the policy framework here does. The policy framework here does is it is responsible for distributing the policy to managed cluster from hub cluster. So if you want to apply a policy, you just create a policy on the hub, and then the framework will distribute it to these policy to the managed cluster based on the cluster you selected. And once the policy is distributed to the managed cluster, it will be executed and evaluated by the policy engine running on the managed. Once there's a result, the policy framework will also collect the results back to the hub, so that you don't have to log into each managed cluster to take a look at what's going on. You can all see them from the hub. The framework itself doesn't have the framework itself supports multiple policy engine and policy language. So if you want to, so it comes with some default policy engine which listed below here. So we have configuration policy, certification policy, and IAM policy. It also supports a third-party policy engine, for example, very popular policy engine Gatekeeper. So the framework itself doesn't really care what language you're using. What it does is it just distributes the policy to the managed cluster and collect the results. That's how the framework itself is designed. So this allows the framework to be extensible so that you can bring additional policy language and policy engine into the framework, but still leveraging the same mechanism to create a policy and collect the results back. So that's the beauty of the policy framework in Open Cluster Management project. So as I mentioned, so there's a component on the hub. So this component is responsible for two things. First is to replicate the policy you create in any namespace and put it into the cluster namespace, and then collect and aggregate the results from the cluster namespace into the original policy. We call it the root policy. And the components on the managed cluster, so these spec sync, status sync, template sync controllers, what they are doing is just as what the name of the controller. So spec sync controller is responsible for copying the policy you created on the hub in cluster namespace to manage cluster. The status sync is responsible for collecting the results and send it back to hub. And the template sync controller is going to extract the policy you create on the hub and then create it on the managed cluster, which I will show you later, an example. Also, so once the policy is applied on the managed cluster, so the policy engine running on the managed cluster will take it over and then execute it. Once it is executed and generates some results, we do design a contract for the policy engine to be able to report status to the policy framework. So we are leveraging events system here, so Kubernetes events. So once once the policy is being executed and generate results, it will generate an event on the policy, the parent policy we call it parent policy, and then the policy will be the results then will be collected by our status sync controller and send it back to hub. This is a very high level architecture. So now I'm going to show you some of the CRDs so that you can have some clear understanding. So the policy CRD, as you can see here, the API version is policy.openclustermanagement.io. Behind is policy. This CRD acts as a vehicle to distribute the policy to manage cluster. If you look at the syntax here, so we have policy templates here, and here there's a description. So use object definition to wrap policy resource to be distributed to the managed cluster. So if you look at the details of this, we embed the whole actual policy CR inside this CR. So the reason we designed this way is that this provides you the ultimate flexibility for whatever policy language you want to use. So here in this example, we use configuration policy. So the entire configuration policy CR is embedded into this policy CR. So when the policy framework, when this policy is created on the hub, the policy framework will bring this policy as a whole to the managed cluster, and then the framework will extract this CR created on the managed cluster, and then the controller responsible for monitoring this kind of policy is going to take over and then apply it. So the good thing is that so you can embed whatever policy inside here if you want, and as long as you follow the contract we designed to report status back, then you can also report status back through policy framework to hub. There's also so we also leverage placement binding CRD. So just like row and row binding, the placement binding CRD is used to bind the policy with actual placement rule. So placement rule, probably you're already very familiar. This is actually an API from application. So we leverage the same API to select cluster. So when you create a policy, if you want to be able to distribute this policy to cluster, you will have to use placement rule to select expected cluster with labels, and then use the placement binding to bind the rule and policy together so that the policy framework knows, oh, this policy needs to be distributed to which cluster. That's what you need to do when you, if you want to create a policy and using policy framework to distribute it to the managed cluster and collect results back. Now I'm going to do a quick demo how the policy framework itself works. If time permits, I will also show you how you can quickly bring, for example, the gatekeeper engine into the policy framework without writing any code. So in my next demo, I'm going to create a policy. That policy is going to using the configuration policy controller we provide in Open Cluster Management. It is going to make sure your managed cluster has certain pod created. So that's the first demo I'm going to do. By the way, so the Open Cluster Management website has been updated to show you how to install policy framework and policy controllers. So here, there's a step-by-step guide here. So I do want to highlight here is the policy framework. Of course, you will have to install. You will have to have cluster first. So you need to install Hub and install Clusterly. And then since the policy framework leverages the placement rule API from application, so you will also have to install application in order for the policy framework to work. Once you have these installed, you can just follow the instructions here to install policy framework and also the out-of-box policy controllers we have as part of the Open Cluster Management project. The configuration policy controller, certificate policy controller, and IAM policy controller. Let me bring my command line. So here, let me first show. So I have two clusters running, so on time, so one hub and one managed cluster. To save some time, I have already deployed deployed the policy framework and controllers. So if you look at on the hub in Open Cluster Management namespace, I have the policy propagator pod running on the hub, and on the managed cluster side, the Open Cluster Management Agent add-on namespace, I have other 3 pods from the policy framework itself, and then I have configuration policy controller deployed. So this is my setup. So now what I'm going to do is I'm going to just use the instructions here. So basically, after you have deployed the policy controller and policy framework, now I'm going to create a policy. Let me move my window here. So this window, I'm currently looking at any policies on the hub. Currently, there's no. And in this window, I'm currently looking at any policies on the cluster 1, which is the managed cluster, and there's no. And now I'm going to apply the policy. So I'm going to switch to the hub and then apply this policy. This policy is available in Policy Collection repo. Policy Collection repo is a repo that we put our sample policies and policy library there, and it also has contributions from the community that what policy you can use. So in there you can find like gatekeeper policy, kernel policy, and etc. So now I'm going to apply this policy. So as you can see here, 3 resources were created. So the policy itself, the binding, and the placement. As you can see, one policy showed up on the hub in default namespace. But currently, it is not being distributed to the managed cluster. This is because if you look at the placement rule here, so if you look at the placement rule here, So it is currently selecting a cluster with label environment dev, because my cluster doesn't have this label, so it is not returning any cluster. So what I'm going to do now is I'm going to patch displacement rule so that it will return the cluster that the managed cluster that I have called cluster one. So I'm patching it. So if we look at the displacement rule again, it is now showing decision cluster one. And if you look at it on the hub, now the policy has been replicated by the policy framework on the hub and copied into cluster namespace for the cluster one. And if you notice that the policy has been renamed with namespace prefix, that's because the policy framework does support multi-tenancy. So if you have RBAC set up and you can restrict user to have access only to certain namespace and create policy there. That's why we prefix the default namespace to the cluster namespace. So for example, if you create another policy called the policy pod in a different namespace and still wants to apply this to the cluster one, so that will help us to avoid the conflicts here. And if you look at the policy on the managed cluster, now it is the policy has also been propagated to the managed cluster. So what I'm going to do here is I'm going to take a look at this policy status. I'm still on the hub. If you look at the root policy, this root policy, we call it root policy because this is the source of the policy. So currently it is not compliant. It has these placement rules and placement binding, and the status is on cluster one, it is not compliant, and the overall status is non-compliant. If we look at the replicated one on managed cluster, I'm still on the hub when I'm looking at the replicated policy in cluster namespace. Contains more information here. So it will show you, oh, this policy is non-compliant and why. So since what this configuration policy does is it is going to check if you have a pod with called Nginx pod, called sample Nginx pod using this image. But currently it's not compliant because that pod doesn't exist on my cluster. So if I switch to the managed cluster, I'm switched to the managed cluster and then look at the policy on the managed cluster. It contains the same information. So what's behind it is the policy framework on managed cluster received the results generated by the configuration policy controller, put it into the replicated policy in the status field, and then the policy framework will take this result on the managed cluster, send it back to hub. That's why you see the same results on the hub in the cluster namespace, and then the policy framework code controller on the hub will eventually aggregate those results in each cluster namespace and to the root policy. That's why you see in the root policy, the overall status is non-compliant. So if you want to look at the overall status, you can take a look at the status field in the root policy. If you want to know more details why this policy is not compliant per cluster, you go to cluster namespace on the hub and look at the status field of each. It will provide you more insights to the reason why the policy is not compliant. So now what I'm going to do is I'm going to enforce this policy because the configuration policy does support remediation, so it will automatically correct any non-compliant for you at runtime. So what I'm going to do is I'm going to enforce this policy so that the configuration policy will correct the misconfiguration for me. So I'm going to switch back to hub because all you need to do is to update the policy on the hub. So what I'm going to do is I'm going to edit the policy, the root policy. I'm going to switch the remediation to enforce. I'm setting it at a global level, at policy CR level. That's because you can, if you notice that the policy templates here is an array, you can provide multiple policy inside one, policy inside one policy, and setting it globally allows me to enforce all the policy it has. So I'm doing it at a global level. Now I'm going to save it. Give it a few seconds for the policy controller to reconcile. We can take a look at the policy on the hub. Its status field. So now, actually, the policy is not compliant. So previously it was not compliant, but after I enforced the policy, it is now compliant. So why is it compliant? Let's get more information by looking at the Replica policy in cluster namespace on hub. Policy dash cluster 1. So if you look at here, this policy, Replica policy on cluster 1 is also compliant. And if you notice that now, previously this was previously it was non-compliant because the pod is missing, and then it turns to compliant because the configuration policy controller on the managed cluster found the pod is missing and the policy is being enforced. So it creates that pod for you, and then after the next check, it finds that the policy exists, and then this policy is also is compliant. So you actually see the 3 history here. So we do provide ability to store history up to 10. So you will see last 10 compliant and non-compliant message as a way to trace what's going on the managed cluster. Now I'm going to switch to the managed cluster. So we have already checked the results on the hub. Now we go to managed cluster to make sure this is actually true. So same. So on the managed cluster, there's a cluster namespace and the policy is there, right? So it will have the exactly same same results as the one on the hub. And then we look at the configuration policy, which is the policy being delivered, the actual policy being delivered to the managed cluster namespace. So these status fields are being filled by the configuration policy controller running on the managed cluster. So you will see very similar status here. And if we look at the pod in default namespace on the managed cluster, get pod, you'll see this pod is being created 3 minutes ago. So I can delete this. And delete this pod since the policy is still being enforced. So once I delete this pod, it is going to be recreated by the policy as the policy was being enforced. Now it's being deployed. Let's take a look again. It's not there yet. So the configuration policy corrects your configuration at runtime. So as you can see now, after next reconcile, it finds the pod expect pod is missing, so it gets recreated 2 seconds ago again. So that's a very quick demo of how you can use policy framework plus configuration policy to apply a configuration policy on your managed cluster. So
Are there any questions for you, Sal? Thank you so much for the presentation. Sorry that I cut you off there, Yusel. Were you gonna say something else?
Yeah, one more thing I want to show is I would like to do some cleanup. So what you need to do is to remove the policy, just delete it from hub. So once I delete this root policy, all the replica policy will be deleted and removed from hub and managed cluster. Yeah. I think we are getting close to the end of this session. So I think what we are, so today I briefly explained how the policy framework itself is working. So I think in next session we will go deep dive on each single policy engine that we support. For example, the configuration policy, it is really powerful. It can be used to configure your cluster, and also it can be used to integrate with third-party policy engine like Gatekeeper, Caverno, and we also have third policy controller and IAM policy controller that we can deep dive. We can do deep dive in the follow-up sessions. That's it for me.
Thank you so much, Yusel. This is really exciting, right? This centralized policy control from the hub side allows us to enforce the policy for security, not only security but application delivery as well, and then it really gives us the visibility for compliance. with the cluster lifecycle piece coming up, it might even be able to allow us for enforcement on the clusters itself for infrastructure. So thank you everyone for joining the meetings. If you have any questions, please post on Kubernetes Slack because we are out of time this week. And next week, as you mentioned, we're going to continue with the policy discussion. Thank you so much, everyone. Take care.